So in this lesson now, we are solving quadratic inequalities. So here we're just reviewing, looking at a quadratic equation like what we've solved in the past. Now, this quadratic, x squared plus 4x minus 12, is the graph. So like looking at the graph, what are the solutions? Well, where is it crossing the x-axis? Here at 2 and -6. So we can state that x is equal to -6 and +2. Then here, just going back reviewing solving, so x squared plus 4x minus 12 is equal to 0. So if I wanted to solve by factoring, now what two numbers multiply to get -12, right? So I need two different signs, a positive and a negative, and add to get 4. +6 and -2, which means then changing the signs, right? Because that's x plus 6 is equal to 0, so x is equal to -6 and +2. So notice the matching. So the reason why we're reviewing this is because we could use either method to solving the quadratic inequalities. So first, we're going to write this as the corresponding quadratic equation. Keep in mind, we're in the end solving for greater than or equal to. So x squared plus 4x plus 3 is equal to 0. So now I'll go through and solve this by factoring. So here, what two numbers multiply to get us 3 and add to get us 4? Well, 3 and 1, x plus 3 and x plus 1, which means x is equal to -3 and -1. Now, let's just say, Ms. Reiner, I'm not a fan of solving by factoring. Well, again, that's why I showed the graph. So you could graph x squared plus 4x plus 3 in Desmos. So here, so here it is. Now notice, where is it crossing? At -3 and -1. So here, that was the solution. So now, what we're going to do is, we're going to take these zeros and we're going to plot them on a number line to create 3 different regions. Now, because this is greater than or equal to, so we are including, because of that equal, I'm going to create a solid line including -3 and -1. So notice by doing that, I've created 3 regions, 1, 2, and 3. And we're going to choose a value from each of these to test. And this is what we mean by testing. But let's choose a value. Now, because we've included -3, I could choose -3, but I'll just go ahead and put -4. So then here I see -2, and here I'll use 0. So we are now going to test the original to see if this is a solution. So we're focusing on -4, -2, and 0 to see if they're solutions. So we're going to use now the original x squared plus 4x plus 3, right? So x squared plus 4x plus 3. And we are going to substitute -4 in for x. So this is -4 squared plus 4 times x. Again, x is -4, then plus 3. So now here we are going to calculate -4 squared plus 4 times -4 plus 3. And we get 3. Now, going back to the original, this is greater than or equal to 0. So is 3 greater than or equal to 0? Yes. So this section is a solution. So now let's go to -2. So again, we are using x squared plus 4x plus 3. We're going to plug in now -2 in for x. negative 2 squared plus 4 times negative 2 plus 3. So now here, we're going to plug in, and we're going to get negative 1. We're going to simplify and get negative 1. Going back to the original, is negative 1 greater than or equal to 0? No. So this section is not a solution. Now let's check 0. So again, x squared plus 4x plus 3. We're going to plug in 0 where we have x. 0 squared plus 4 times 0 plus 3. When we simplify, we get 3. Is 3 greater than or equal to 0? Yes. So this section is also all solutions. So negative 1, 0, 1, 2, 3, 4, 5, 6, 7, they're all solutions. That's an inequality. We're going to have an infinite amount of solutions. So the solution to our quadratic inequality is our first section here, all values less than or equal to that negative 3. So x's less than or equal to negative 3, as well as x's greater than or equal to negative 1. So this is the solution or solutions to our quadratic inequality. So these are the steps that we are going to use to go through and solve. So first, we have to find the equation, find the roots. You can solve by factoring or by graphing. Use the roots to plot on a number line to identify our 3 sections and 3 values that we are going to use. Then plug in those 3 numbers to see if it is a solution. So here, let's just focus on graphing in Desmos. So go ahead and pause the video and graph x squared plus 3x minus 10 in Desmos. And so here, you're going to get this graph. You should have this graph here. So you should see that your graph is crossing at 2 and negative, sorry. So your graph is crossing at 2 and negative 5. So these are the solutions. So 2 and negative 5. So when we create our number line, I'll put 0. We need 2, and I'll keep going, creating my number line, and negative 5. So 1, 2, 3, 4, 5, and then I'll put 6. So negative 5. Now notice we have created our 3 sections. So now let's identify 3 values. So we could choose negative 6 if we wanted to. Now notice I put solid line because this is greater than or equal to. So we are including. So negative 6. I see 0 here. So this was 2. So you know what? Let's go ahead and choose 3, right? So now we've got our 3 sections. We now need to start simplifying using the original to see if these 3 values are a solution, negative 6, 0, and 3. So here we go. Using the original, right? We're plugging in to x. So negative 6 squared plus 3 times x. So 3 times negative 6 minus 10. So again, we're plugging negative 6 in for x here. So now when you simplify, you get 8. Going back, greater than or equal to 0. So is 8 greater than or equal to 0? Yes. So here, this section, all the less than or equal to negative 5 is a solution. So x's are less than or equal to negative 5. So now let's check 0. 0 squared plus 3 times 0 minus 10. So now when you simplify, you get negative 10. So is negative 10 greater than or equal to 0? No, negative 10 is less than. So that means this section is not a solution. So now let's check 3. 3 squared plus 3 times 3 minus 10. So now here when you simplify, you get 8. Is 8 greater than or equal to 0? Yes. So this section, all values greater than or equal to 2, is also a solution. So x is greater than or equal to 2. So x is less than or equal to negative 5, or x is greater than or equal to 2. So go ahead, if you want to practice the graphing, or if you want to factor, you have to first take out the GCF of 2. But if you want to graph it, go ahead and graph it. Pause here and get the graph. And here, your graph should look like this with solutions of 2 and negative 3. So here we go. We are going to plot on the number line, right? So 0, we need 2, and negative 3. Now here we'll create our 3 sections, right? And now let's choose. Well, if this is negative 3, oh, I just realized I made a boo-boo. Hold on. Let's go back. I forgot. Notice. Now we're just doing strictly greater than. You see now the difference? So we're not including 0. There's no equal like before, greater than or equal to. This is just greater than. So we're going to draw a dotted line because now we're not including the values of negative 3 and 2. So keep it open. So let's choose values. Well, this was negative 3, so negative 4, negative 5. So let's just go negative 4, right? Here we've got 0, and here this was 2, so let's say 3. So here we go. We're going to now test those 3 values to see if they're a solution. So here plugging into x, 2 times negative 4 squared plus 2 times negative 4 minus 12. So again, we're plugging in the value negative 4 in for x. So simplify here, and you should get 12. So now 12, is that greater than 0? Yes. So this section is a solution. This is a solution set. So now let's go to the next. We've got 2 times 0. So 0 squared plus 2 times 0 minus 12. Here you simplify and you get negative 12. Is negative 12 greater than 0? No, it's less than. So this section is not a solution. So now let's check 3. So 2 times 3 squared plus 2 times 3 minus 12. So when you simplify, you should get 12. Is 12 greater than 0? Yes. So this is also a solution set. So x's are less than the negative 3 here, right? Because we're starting at negative 3. So x's are less than negative 3, or again, right, we were at 2, greater than 2. So I'll go over one more. Now notice, we're graphing x squared plus 6x because just like the quadratic, even the quadratic inequalities, you have to equal 0. Right now it's equal to negative 6x. So what do you have to do first? Add 6x to both sides. So now you've got x squared plus 6x is less than or equal to 0. So now go ahead and graph this quadratic and identify, and go ahead, try this step on your own. Identify and plot on the number line. So when you graph this, you should see that you had the solutions of 0 and negative 6. So 0 is actually one of our solutions, and it's equal, less than or equal to 0, so solid line, because we're including 0 now. So again, 1, 2, 3, and then negative 6. So 1, 2, 3, 4, 5, 6. So negative 6 is our other solution to divide. So now let's choose our 3. So here's negative 6. So you could use negative 6. I'll choose negative 7. Now over here, this is negative 1 through negative 5. So let's go with negative 1. Then now you could use 0, or we'll just go ahead and use 1. Now let's go ahead and identify. So here we go. So because I have my graph here, I'll go ahead and erase and do the work here. So we are again going to simplify in where it's equal to 0. So where x is, plug in negative 7. So negative 7 squared plus 6 times negative 7. So when you simplify, you get 7. Now, less than or equal to 0. So is 7 less than or equal to 0? No, it's greater than. So now this section is not a solution set. So now let's check negative 1. Negative 1 squared plus 6 times negative 1. When you simplify, you get negative 5. Is negative 5 less than or equal to 0? Yes, it is. So now this section here, this is a solution set. Now let's go to the last one. 1 squared plus 6 times 1. When you simplify, you get 7. Is 7 less than or equal to 0? No. So this is not a solution set. So this answer we're going to write, it's different because the solution set is between negative 6 and 0. So our x's are between negative 6 and 0. So because literally our values and x is here, so negative 6 is less than or equal to 0, is less than or equal to, or x is less than or equal to 0. So that is how we're going to show our solutions when they are between the two values.